So this next bit is going to be a little more complicated simply because there's not as much information about it on the internet. And that's the database, database.go in the design.
Yeah.
So this is a GOA.
Just going to adjust that a little. Keep
going.
going.
I'm a little bit over, yeah.
Yeah, you scoot back or I scooted it around when I changed the battery.
So the database.go, it defines a connection between your app and the database. So this is a little bit counter to GOA's thought behind GOA's normally supposed to be between your app and the internet. So this database thing is actually a plugin written for Greater Commons to communicate between your app and the actual database where all information is stored.
Okay, so you said app, internet, and then GOA is supposed to be right there in the middle, right?
Yep.
Here's your app, here's the internet, and GOA is supposed to be right here.
In the middle.
Meaning,
Go is the tube between the internet and your app.
Okay.
So communicate.
Okay, because it generates all the app code. Is the idea?
So it generates everything your app needs in order to talk to the internet.
Okay. Okay.
So.
And then you're saying with the database.
That's another layer deeper in.
Behind the app.
Behind
that the app talks to. Okay.
Yep.
And then
this is a plugin written for GOA which generates all the stuff for talking to the database.
Okay. Okay. Got it.
So there's let me pull open on GitLab. There is a database repo which has a large amount of.
What's up?
Garage.
Oh, there you go.
My bad.
See ya. No problem.
Sorry about that.
So there's a database repo here, which this is all the code for that database plugin, and it has a README which has as much detail as could be thought of.
Yeah.
In order to all the various functions and such that are added with this plugin. However, this is all the documentation there is on this plugin anywhere because we wrote it.
Yeah.
So if you've got any questions about this at all, please send me an email because that's basically all you're good. You got this and you got me, and that's about it.
And at the end of the documentation, we could take whatever question is there, and you could either make a video as the answer and post it right here, or do a text.
I can update this as questions come in. But however, every feature in it is used somewhere in Greater Commons, so you can generally find an example for every feature. So how this works is you define a table. So a table ends up being just a struct in Go. Mm-hmm. So it's some value you want saved. Let me see if I can find a better, simpler example in a different microservice than that. Trying to think what's a microservice that has a simpler.
Customers, right? Just like it's customer fields, or is that going to be huge?
I'm just thinking simpler for how the actual code handles it.
Take your time. I could totally cut out
design database
searching.
I'm trying to find something without the implement function because that's a little complicated. Where
Take your time. Let's edit all this out.
Implement. It's a handy function, but it's also the most complicated one to describe. Oops, not that. Design database. Okay, here's one.
Okay, so where are we?
So this is
in
pay design database.go. So this is I'm picking this one because it's a little simpler code-wise than some of the other tables. So I'll get to them. I'll get back to them in a little bit. So every a database.go just has a list of tables, a bunch of tables, just var _ equals table. So each table is just one, is describing a struct that you can put into the database. So for example, I've got a struct called teacher purchase. So teacher purchase has information on that a teacher would see about purchases in their course. So within a table, you've got the name, and then you've got a list of fields. So each field is just one value in the struct.
Right.
So, and just like params or in the types, attributes, they're just a name and a name and a type.
Cool.
So the types are are custom. They're not the standard GOA types because I wanted the N64. So here's the list of kinds. So what it will look like in Go and what you will call it in the database.
Nice.
So let me pull that. Where'd it go? There it is. So teacher ID is an N64. An amount is a float 64. A purchase ID is a string. Purchase time is the time. So that's that. One difference between this stuff is you cannot put a description as a third parameter. You can't say this is the teacher ID. It doesn't work. You'll get an error. If you need a description, it does support putting in more details and putting in a description like this. This is a teacher ID. So
cool.
If you need one, it supports it like that. It's not really required because all this does is put the comment in the generated file.
Yeah.
So it's not usually as necessary, but if you're designing a design thing like this and you want a description, that's a way to put the description in. So beyond that, one field must have the func that says key field.
Yeah.
So this is the main field that identifies a particular instance in the database.
Yeah.
So a teacher purchase has an ID. That's the key field. If you've got the key field, you can get that particular teacher purchase. So every single table will have a key field.
And this is set up to go into data store.
So this is all designed to go into Google's data store.
NoSQL.
Yes, which is a NoSQL database.
And so that N64 kind is its key.
Yep, so a key field can be an N64, a UUID, or a string.
Okay.
Which I believe all three of those are specified key field. You have to specify one key field, must be N64 string or UUID.
Nice.
In addition, if you just say key field, it'll be automatically generated by the database. It'll guarantee that this field is not match anything else.
Yeah.
So for teacher purchase, I just say key field. So the database will assign an ID to this when I create it. So when I first create the struct, I don't have to bother filling in the ID field. I just give it to the database. And the database will fill in ID automatically. If you don't want this, you can say no generate, and this will tell it. That basically tells GOA, no, I know what kind of ID I want for this. I will put the ID in there myself.
Cool.
Don't give me one. So most fields you'll just say key field, but every once in a while you'll have something where you want to have your own custom one, so you say no generate. So you can create a table with just fields, a bunch of fields. However, oftentimes you will also want to query information. So say you want to query table purchases by teacher. So this particular query,
I just saw that too.
Yeah. So this particular query, you give it a teacher, and it gives you back all the entries where the teacher.
Oh, that's so awesome.
Matches.
That's the query right there.
Yeah. So this is the query. So you give it a name. So the name, I usually say by something.
Yeah.
Because the final function name will be called query table name and then the query name.
Yeah.
So query teacher purchase by teacher.
Nice.
Or query teacher purchase by purchase.
Nice.
Or query teacher purchase for analytics.
Nice.
So a preposition. Inside you can say filter and sort. So a filter would be how you would get just specific. You're filtering. It's querying through all the fields in the database.
Yeah.
But you want to filter it down to only stuff that matches your filter. So your filter. So this particular filter is the teacher ID field is equal to something that is specified in the code.
Nice.
You can have multiple filters. So here I've got this by purchase, filters by purchase ID and teacher ID are both equal to something.
Yeah.
There's also greater than or equal, less than or equal, greater than or less than.
And this is something you
Use
built,
value.
this whole
These-
thing, this
yes.
entire database.
This entire database language, design language.
Yeah. Wow. Awesome.
So besides filters, there's also sorts. If you want to have the data come back sorted. So in this case, by teacher, I'm going to sort it by the purchase time field in descending order.
Nice.
So there's also ascending.
Very cool.
Again, you can have multiple sorts. There are a couple specifics, like for example, if you've got multiple filters, all filters that are equal must come before unequal filters. However, it will actually detect that particular circumstance, and it will actually just give you an error message that specifically says, hey, all equals must come before not equals when you're querying. So it should be mostly straightforward. If you get an error there, it should tell you what the problem is. So in addition to just the plain filter with a name, with a field name and equal, you can also put in extra stuff. So for filters, you can say optional. So when querying by purchase, you have to put in a purchase ID to query by. You can put in a teacher ID to filter by, but if you skip it, it'll only filter by the purchase.
Nice.
So most of the time that's not needed, but every once in a while it's handy. You can also say in a filter static value. So this is basically this particular query will always filter based on a specific thing. So in this query for here, if you do this query, it wants is dispersed field to be false. If you skip static value, then it's intended to be passed in by the code that's activating this query. So for here, when you're querying by teacher, when your code's querying by teacher, it needs to pass in the teacher ID that it wants to be equal to.
Yeah.
So if something's querying for a purchase that's ready to be dispersed, is dispersed is always going to be false because you're looking for something that's ready to be dispersed.
Right.
So it hasn't already been dispersed. Again, this is another one that's fairly rare to use, but it is there. I believe sort also supports optional. You can also, in a sort, you don't have to specify ascending or descending. If you skip that, then then whatever's calling that query must pass in ascending or descending.
Oh, okay.
Be very careful, however, with leaving this optional in sorts, because it generates a massive amount of indexes in the database to make sure it can sort for every possible way.
Right.
And so that we only have a limited number. It costs us a lot if there's a lot of indexes.
Can we make that required?
So
let's make it required.
So there's like two places in the entire code base where there's a sort where it's
not specified.
Not specified.
Because we want to specify it when it's called one way or the other.
Yes. So by specifying it like this, it only has to generate one index.
Yeah.
So it only has to make sure it's got an index for descending purchase times. It doesn't have to have both. So, but if you are writing something that can do either, it is possible to do it like that. Don't recommend it though. Again, all of this is located in here. So like here's no generation.
Yeah, we're at GitHub Greater Commons database.
Yeah.
So just right at the root of the database.
Queries. GetAll. A GetAll is a query with an empty. It's just a query. You're getting everything. So in this, if you got a table bottle, and you want to query you want to get every single bottle, you just say you have a query with no filters.
Yeah.
You can sort. You can have multiple sorts if you want. The first sort is the primary sort, and then you got additional sorts that are applied if they're equal. So this is sorting bottles by age first, and then by name. optional sorts and choosable directions. You can make a sort optional by using optional. You can also make the direction skippable by skipping ascending or descending. If a sort's optional, the direction must be choosable. That's just a limitation of how we coded it. Not really something that should be that way, but it does exist. Filters, or as I explained, filter is the name, and the comparator, which I'm not entirely sure is spelled correctly, but comparator, equal, less than, etc.
Right.
It can be optional. It can be a static value. Oh yeah, and I forgot about pagination. So
cool, pagination.
Yeah, so filters and sorts most queries will just be filters and sorts. However, if there's a table where you're going to be querying it, and it may give back a massive amount of stuff, like for example, querying all the courses on Greater Commons. Right now that's pretty small, but eventually that's going to be big.
Yeah.
Too big to want to do in a single call.
Yeah.
So if you got one of those, you can say per call in your query, and you specify how many results you want per call. So like this example here, if you got a table of bottles and you want to get all bottles, but you only want 20 every time you call the query. This will make it so that when it makes the actual query function, it will give back a bookmark, which you can use to resume the query, so you get the next 20 items, and the next 20 after that.
Nice. That's so cool.
Which is
totally helpful.
It can be helpful, yes.
Yeah.
It can also be a little bit of a pain to mess with the bookmark and make sure it's saved so you can resume it later and all that. But if it's necessary, we've got that functionality.
So the bookmark would be something that you would pass back in the URL parameter probably from the client. I was at, last record equal 20 comes back, it picks that up and says, okay, now I want 20 through 40, and then it goes to the client, and then the client says, well, give me next, right? Or maybe whatever it is, maybe it's next record 40, right? And then 40 to 60, or maybe they went backwards, next record 0, now 0 to 20 again.
So you cannot go back though. Oh. It's just a bookmark for that point.
Going forward. Okay.
Yeah.
All right.
So we usually use that. Our front end's mostly designed around infinite scrolls instead. You scroll to the bottom of the list and it puts 20 more items on the same page. Yeah.
It doesn't go back because you can't say starting point for the next 20.
If you still have that bookmark, you can take that bookmark point again.
Getting into the details.
Yeah.
But maybe it's something needs a little improvement, but it's probably pretty good to go.
It works. It works as is for now. So,
cool.
So two more things you can put into queries is keys only.
Yeah.
If all you care about is the ID or something, you can say keys only. So, this is handy, for example, when you need to delete everything that matches your query. So say you've got a table that's every entry is supposed to expire after a week. You make a query that sorts for everything older than a week, and you say, I only want the keys, because all you need is the keys in order to delete the entries in the database. It's used fair bit amount in the code base, not too often, but
makes sense. It's keys only.
Yeah, you're only getting the keys.
Right.
So that means if, for example, if I had a keys only, so this table is a struct called teacher purchase. If I had a query that said keys only, it would return back a slice of int64s instead, because that's the key field.
Yeah.
The last thing you can throw into a query is only first. This is most often used for, you can guarantee just the way that you're coding the database, this query will only return one result.
Yeah.
So if you do that, you say only first, and it will return just the first entry instead of a slice.
Cool.
So if you guarantee, if you know it's only gonna have one result,
right,
say this, and you won't have to pull it out of the slice.
Yeah. Cool. Nice.
So that's all the query possibilities.
Beautiful.
Trying to think what else. Oh, no index. In a field, you can say no index, and you are not allowed to query on a field that doesn't have an index. You cannot have a filter you can have a filter. You cannot have a filter that specifies a field with no index. You can't have a sort that specifies a field with no index. It's just not allowed to do anything. You can only get and pull. You can only set and get stuff that's a no index. The reason to use this is that an indexed string has a maximum length, but an unindexed string does not. So if you got, like, say, the description of a course, you're not ever going to query on that. So you make it you put no index on it, so it's got an unlimited size in the database.
Okay.
And then, so that's just an app engine, a data store kind of restriction. Is index stuff has a maximum length.
Okay.
So if you got a string that's that might be large, don't index it.
So you would use. So here's an example var bottle table, and then you just run no index right there for that field. You pass in the func, and you say no index because now the field content is not going to
you won't ever
table bottle the field content will never be indexed because it's going to be a long string. And data store doesn't index long strings.
Yes.
It only indexes strings up to what size?
Like 5,000 characters, I think.
Oh, okay. But also, like, maybe we just don't ever want to search on that, so don't bother building an index here.
Yes.
Because that just costs us money.
However, you do want to preemptively index when you can, because even if you're not actually filtering on it, because if we eventually do later on need to filter on it, we then have to we have to retouch every field in the database in order to add the index to it.
Okay.
So only put no index if you're going to guarantee you're never ever going to put a query up that needs that.
All right.
And I guess the last bit is the complicated one that I was trying to avoid earlier.
Let's do that in the next video because we're at 21 minutes.
Yeah.